Our primary mission is to support launch operations here at Vandenberg. We help with forecasting the transport of fuels and equipment into building the rocket. We help decision makers determine when is a good time to launch the rocket, and then the day of, we are always there by their side throughout the count to determine if it's safe for them to eventually launch the rocket.
We monitor this 99,000 acre range around the clock. Essentially, we look out for things like watches, warnings, advisories, kind of the things that you would imagine National Weather Service office doing. That kind of comes from our range weather forecaster. They're the ones that tell us if there's going to be strong winds or if we have to issue a watch for lightning, things like that.
Clear skies, no wind. That is optimal. However, that occurs like 10% of the time. Normally there is some cloud cover, which doesn't really affect the launch, but you can't see it, and everyone wants to see the launch. But there's almost always some level of wind. And depending on the rocket and the location, it can have major impacts to being able to launch.
Out here, it is rocket science, and so we have to be very, very precise. Some of these rockets are sensitive to the nearest mile per hour, to the nearest degree of temperature, the nearest wind direction. Small changes in wind direction and wind speed have a huge impact on the spacelift mission here. So we have to be very good at what we do.
We are fortunate to have one of the most robust instrument networks on any military installation. We've got 26 different wind towers with over 200 different instruments altogether. To have access to all that data helps us make an enormous amount of decisions, especially for a base as large as this one. 99,000 acres is a lot to cover and be able to forecast for.
So this is the upper air observatory where we fill our balloons with helium, attach our radiosondes to them, and release them.
Balloons are really important, specifically for range safety. Their models determine where the debris will fall if a mishap occurs, or what will happen to the shock wave from that blast.
This is a Lockheed Martin LMS-6 radiosonde, and basically measures the temperature, wind speed, pressure, and humidity up in the upper air. These will typically go between 100 and 120,000 feet. Typically when it gets up there, the balloons tend to expand to about the size of like a Greyhound bus or so. So they actually get quite large.
A good portion of the reason why our weather models are actually quite good for large-scale features is because of satellites. We ingest a lot of data into our models to run them. If you look to the west, there's a lot of water. The Pacific Ocean is large, and there's no balloons being launched from there, no consistent surface observations. So you have a large area of data-sparse surface and atmosphere. So the way that we get around it as a career field is we ingest satellite data into our models to fill in the gaps. It's not perfect, but the more satellites we get and the better satellites we get, the better we can expect our models to perform because there's gonna be more data to actually compute with.
I believe that the weather should always be respected, but never feared. Much in the same way that you would think about wild animals. Wild animals are so cool to look at, but you don't want to get tangled up with one, especially if you're not a professional and you don't know what you're doing.
This is my favorite job I have ever worked. I'm a weather nerd. I love weather. I've loved weather since I was 11. I know we don't get tornadoes like in the Midwest or big thunderstorms like in the Cape, but it is very interesting to focus on just how the terrain can affect weather and operations.
For me to be able to contribute to the mission of providing weather and climate and all those things to not just the military, but the world at large, that's very humbling. And any way that I can help contribute to the advancement of meteorology and climatology as a science, I would happily do so. And that's the military gave me the ability to do forecasting. That's why I joined. They said, hey, you want to be a forecaster and be a weather officer and do those things for the military? I said, you bet.